Hello, this is Mr. Weideman, Lafayette High School, Regular Physics. This is problem number 56 from our unit on universal gravitation and planetary motion. If you're watching this video, you're probably a little bit confused about what to do on this problem. It's very tempting to plug and chug away at this and enter lots of big numbers into Newton's universal law of gravitation and calculate the mass of the spacecraft and run lots of numbers, and it's not necessary. Take a look at these numbers that we're using for an altitude, and in this problem it's no coincidence that the altitude happens to be the same as the radius of the Earth. Let's kind of visualize this information that we have here. Okay, so we're starting right here, and here's our 7,200 Newton spacecraft right here on the surface of the Earth, one radius away, and we're told that the gravitational force at that radius is 7,200 newtons. Okay, so now let's add an altitude equal to one radius of the Earth. And the temptation is to get out our calculators and start running a bunch of numbers. But that's not necessary. What I need you to look at here is the radius has doubled. So if we just simply put a 2 in the denominator of our inverse square law and square it, we're going to see, and we've kind of talked about this before, as I double the distance, I will have 1/4 the gravitational strength. Let's pull this problem out another. If we need to see that 1.28 is now 3 times 6.38 times 10 to the 6 meters. Okay, so now at this point, we are triple the original distance from the center of the Earth. And from our discussion of the inverse squared law, that we see then we're at this altitude right here, we have doubled our distance, therefore our gravitational force will be 1/4. As we come out here, we've tripled our original distance. Now the gravitational force will be reduced to 1/9. And then we actually can solve this problem by just multiplying 7,200 newtons by 1/4, and then multiplying 7,200 newtons by 1/9, and then we have the gravitational forces at this altitude and again at this altitude.